Today's lesson is going to be solving equations with whole numbers. There's a couple of important notes that we want to know. The first one is you must get the variable or the letter alone on one side of the equal sign. When the letter is on one side, the answer will be on the other. The second, you can get the variable alone by using the inverse operations to undo what's being done to the letter. And finally, the most important, what you do to one side of the equal sign, you must do to the other. Properties of equality. We're going to try two of each. You write x plus 14 equals 29. Notice what's being done to the x is we're adding 14. That's what we want to get rid of. You're adding 14 to x, so you have to do the inverse operation to get rid of it. Therefore, we subtract 14 from x. What you do to one side, you must do to the other. And it looks like this. On the left side, it's going to cancel out, leaving just the x, which is what we wanted. And on this side, it will actually give us the answer. X equals 15. 9 minus 4 is 5, and 2 minus 1 is 1. Now we need to check our answer. We're going to use substitution like we did in the variables and expressions film. We're going to take the 15, take the x out, put the 15 in its place, solve the original problem, and if it's correct, then we've done it correctly. Is 15 plus 14 29? Yes, and we did it correctly. Let's try one more addition. You ask, what is being done to the A? So if you look at the A, we're adding 15. Since we're adding 15, we need to do the opposite, which is subtract 15. And what we do to one side, we must do to the other. So it looks like this. The left side will cancel out, leaving the letter A. And this side of the equal sign will give us the answer, 23 minus 15. And A equals 8. Now we're going to use substitution to check our answer. We're going to take the 8, put it in the A's place, and solve the original problem. Is 8 plus 15 23? Yes, it is. You are correct. Let's try subtraction. You write y minus 12 equals 15. You're subtracting 12 from y, so you need to do the inverse operation to get rid of it. Therefore, you will add 12 to y. And don't forget, what you do to one side, you must do to the other. So it will look like this. The left side will cancel out, leaving just the letter y. The right side will give you the answer. 5 plus 2 is 7, and 1 plus 1 is 2. Now we're going to use substitution to check our answer. Put the 27 in the y's place, work the original problem, and if it's correct, we did it correctly. Is 27 minus 12 15? Yes, it is. Let's try another example. N minus 37 equals 42. You ask, what is being done to the n? We're subtracting 37, so we have to do the opposite, or add 37, and what we do to one side, we must do to the other. So it will look like this. The left side will cancel out, leaving just the n. The right side will give us the answer. N equals 79. Notice 2 plus 7 is 9, and 4 plus 3 is 7. Now to check our answer, we're going to use substitution, put the 79 in the n's place, and work the original problem. Is 79 minus 37 42? Yes, it is. We are correct. Now let's do multiplication. you write 6s equals 180. Notice when it's side by side, that means multiply. So we are multiplying s by 6, so we need to do the inverse operation to get rid of it. Therefore, we have to divide by 6. What we do to one side, we have to do to the other, so it will look like this. Notice this line means divided by, so this is 6s divided by 6 and 180 divided by 6. The two 6's will cancel out. 6 over 6 is 1, and 1 times s is s, so it leaves s by itself. This side will give you the answer. 180 divided by 6 is 30. Now we're going to check our answer. We're going to put the 30 in the s's spot and see if it equals 180. 6 times 30 is 180. Let's do another one. 3n equals 72. You ask what is being done to the n. We're multiplying the n times 3. Since we're multiplying by 3, we have to do the opposite to get rid of it, which is divide by 3. And what we do to one side, we must do to the other. So it would look like this. The two 3's will cancel out, leaving just the n, and this side will give you the answer. 72 divided by 3 equals 24. To check our answer, we're going to take the 24, put it in the n's place, and work the original problem. 3 times 24 is 72, and we are correct. Let's do 2 division. You write m divided by 5 equals 24. Notice this line means divide by. M divided by 5 equals 24. Since we're dividing m by 5, we have to do the opposite to get rid of it. So we're going to multiply by 5. And what we do to one side, we must do to the other. So notice we have the original equation, and we're just multiplying both sides by 5. The 5 on this side will cancel out, leaving just the m, and this side will give us the answer, 24 times 5. M equals 120. To check our answer, we're going to use substitution. We're going to put the 120 in the m's place and work the original problem. 120 divided by 5 is 24, and we are correct. Let's work one more. M divided by 12 equals 24, and you ask what is being done to the m. We're dividing by 12. Since they're dividing by 12, we have to multiply by 12 to get rid of it. And what you do to one side, you must do to the other. So it looks like this, where you divide the original equation, both sides, by 12. The side on the left cancels out, leaving just the m. The side on the right gives us our answer. 24 times 12 is 288, and the m is just dropped in. Now we're going to check our answer. 288 divided by 12 is 24, and that is correct. Now it's time for lots of practice. You're going to be the detective and solve the equation. Follow the steps, and it's easy. The first step, isolate the variable by using the inverse operation. What this means is to get the letter by itself on one side by doing the opposite of what's being done to the letter. What you do to one side, you must do to the other. This is because of the properties of equality. The variable will be on one side of the equal sign, and the answer will be on the other. And then always check your answer by using substitution to make sure you are correct. This concludes our lessons on solving equations with whole numbers.